I'm going to do that. And now I'm going to go back to share screen. Okay, well, hello everyone, and welcome to the St. Louis Java Users Group. This is the October 2020 edition. Hopefully everybody can see my slides here. Why don't you wave at me, Ted, if you can. And good. All right. So the St. Louis Java Users Group is a pretty informal group. Attendance is free. We don't have a formal membership list, but our normal meeting date is the second Thursday of every month except December when there's no meeting. We just have too much going on for the holidays to be able to schedule a meeting then. When we meet in person, you can join us for food and social at 6 p.m. and the actual meeting starts at 6:30. When we meet in person, we would normally meet in the Object Computing Incorporated training room at 12,140 Woodcrest Executive Drive, that's Suite 310 in St. Louis, Missouri. But because of the pandemic, we've been meeting online. And we thank you for coming and putting up with all of this. Yet another Zoom meeting. I bet some of you probably just live. Anyway, let me introduce the other members of the steering committee. So from left to right, we have Ted Doyle, then Todd Zimmerman, Bruce Alspaw, that's me in the middle, Wei Chi Gao, and Kathy Zwang. And you can reach all of us on the steering committee if you just send us an email at javasigsc@ociweb.com. I'd like to thank the sponsors of the St. Louis Java Users Group. Our initial inaugural sponsor, who's been with us since the founding of the St. Louis Java Users Group, is Object Computing Incorporated, and they sponsor our web hosting, and we have an email list, and right now they're sponsoring the room when we meet in person. We also have JFrog. They're a new sponsor, and they're sponsoring the fees so that the Jug can have our own Zoom account, which you are on right now. And they also have a raffle prize here. I'm going to show that in just a minute. And they also sponsor the fees for the meetup group. It's free for you to register an RSVP to come to our meetings on Meetup, but it does cost the group that we have to pay a subscription fee, and they've covered that for us. Signature Consultants and Adaptive Solutions Group are both headhunters, staffing agencies, and they will, when we meet in person, will sponsor food for the meeting, but we just haven't figured out a good way to transfer pizza over the internet. But when this pandemic is over, I'm sure they'll be back. If you're looking for a Java position, just do a Google search, they'll turn up, and just tell them that you heard about us through the St. Louis Java Users Group. They're great folks. JetBrains has been sponsoring some JetBrains licenses for us, and we'll be raffling 2 at the end of the meeting. So I should probably announce how you participate in that. You probably see Ted Doyle somewhere as one of the participants. He's waving at you right now. If you can send a private message to him with your name and email, he will enter you into the raffle at the end of the meeting for a couple of JetBrains licenses. Also, Elastic has been sponsoring some gift cards for us. We haven't figured out a way to send those through the mail, but we haven't figured out how to send the Intertech Flying Screaming Monkeys yet through the mail. But Manning, those are electronic. We have 2 ebooks from Manning that we'll be giving away at the end of the meeting, and it's the same way. Just send a private message to Ted Doyle and with your name and email, and that will get you into the raffle at the end of the meeting. Pearson will also on occasion sponsor some physical books, and we'll just accumulate those, and once we're meeting in person, well, we're just going to have a nice big giveaway. Now, speaking of JFrog, let me put up their slide. Ted, why don't you wave at me if you can see that one? or somebody. Okay, good. Everyone can see that. It says enter for a chance to win Apple AirPods Pro, sponsored by JFrog. So you'll see on this slide, we have a bit.ly link and a QR code for that raffle. And also I've entered that bit.ly link into the chat window so that you can find the link there as well. So you can just click that link and it will take you to the website where you can enter your information in if you'd like to be in the JFrog raffle for the AirPod Pro. And JFrog tells me that they're going to select those winners within the next couple of business days. So I'm sorry if you're watching the recording, you're too late. It's not going to work. Sorry. It's only for the people here who are actually at the meeting. So back to our slides. We do have some upcoming presentations on November 12th. We have Modern Java Clients with Java FX, the definitive guide, by Stephen Chin of JFrog. Stephen is a co-author of an A-Press book, along with one of our other steering committee members, about Java FX. So I'm looking forward to that one. And as I mentioned before, there will be no meeting in December due to the holidays. But I'm working on a meeting here in January, and details are coming. It'll be surviving dependency hell with Maven. In other words, when you have a Maven dependency and it has all these other dependencies that are transitive dependencies, and then you pick another dependency and it has transitive dependencies, and all of a sudden those transitive dependencies are in conflict, what do you do about it? Well, Ray can tell you what to do, and they've actually got some tools for Maven that can help you out with that. So I should also mention that if you want to keep up with our presentation schedule, just watch the Meetup site. That's the meetup.com/gatewayjug, and you'll see all the latest updates as soon as I can get them posted on a presentation schedule. And you can go ahead and RSVP for them as soon as I put them up there. So like you can RSVP for November right now if you'd like to. Now, if you're interested in giving a presentation or sponsoring the Jug, just send us an email to javasigsc@ociweb.com, and that'll go to all of us on the steering committee. So with that, I'm going to be turning it over here to Venkat for the presentation. So what I'm going to do is I'm going to stop sharing my screen, and then I'm going to throw it over here to Venkat, and I'm going to click this Make Host button, and I'm going to say, oh, I see your screen now, and I'm going to click yes, and Venkat, I trust you, you're the host. So why don't you take it away, Venkat?
Thank you, Bruce, and thanks to all the other members of the group. I want to thank everyone who has joined. I really appreciate you taking the time. Along the way, if you have any questions or comments, please post them on the chat. I'll be delighted to answer them along as I speak. So don't hesitate, don't wait till the end. Anytime is a great time for questions or comments. I'm thrilled you are here, and let's get going. So what I want to do today is to talk about Java, where Java is today and where Java is heading in the coming years. So it's very exciting time for Java, and I want to talk about what we're going to do and how we can make use of Java itself. So when you look back at Java, it's incredible to think that Java is right now 25 years old. Oh yeah, so if you want to keep your videos on, please do that. That's awesome, because it's a lot more easier for me to speak knowing that there's a human on the other side than to speak at a blank screen. So I really thank you for keeping your video on. If you're able to do it, you're most welcome to do it. Thank you so much, appreciate it. Awesome. So it's incredible to believe that today we are at 25 years of Java. That is an amazing journey. But I do have to admit one thing though. I was that guy on the other side of the picket line, constantly complaining that Java is moving too slow. And that was the time of about Java 6 and Java 7, the doldrum days of Java. And Java was extremely slow in its growth, and the excitement of Java in the beginning kind of tapered off. And of course, all that changed when Java 8 came. And honestly, Java 8 was the game changer for me. Even though I started using Java very early on, I kind of started looking elsewhere along the way because Java was not going at the pace at which I really wanted it to. And jokingly, I often say that around Java 7 timeframe, Java was on the deathbed. They brought in the priest, they were citing the last rites to it, and all of a sudden Java 8 was released, and you could see Java running on the park and having a great party. And you're like, gosh, how did that even happen? Well, Java now is a very different language than it was only about 10 years ago or even 5 years ago. And the pace at which Java is moving is incredible. And that's what I want to focus on today in our discussion. Well, quickly, Java 8 was a really big game changer. Before the time of Java 8, we programmed in imperative style and object-oriented style in Java. With Java 8, we are able to program not only in imperative and object-oriented style, we can also program in functional style as well. And two things that made the difference for us was Lambda expressions and, of course, the streams API. And with Lambdas, of course, we are able to use higher order functions to pass functions to functions. Streams provide us the lazy evaluation, and that was remarkable. In fact, I'll quickly mention this. To me, functional programming really is equal to two things. And one of them is functional composition. And this is where you're able to do one function and like a builder pattern, if you will, and you're able to do this functional composition, but more so plus the use of lazy evaluation. And that's extremely important for us to be able to enjoy the functional style of programming. So functional style of programming with functional composition and the lazy evaluation was the cornerstone of Java 8 in terms of what Java 8 actually provided for us, which was absolutely phenomenal. Now, of course, from Java 8, we moved on to Java 9, and Java 9, of course, introduced modules. There were a lot of interesting things that Java 9 brought to the table, but one of the most significant things that Java 8 brought was really the concept of modules. And while Java 8 really helped us to provide us with functional style of programming, it was still an opt-in and opt-out for most part. On the other hand, when it came to Java 9, it was a completely different story. And Java 9, of course, what it gave us was the ability to deploy the applications very effectively. And as a result, Java 9 modules is not about you and me. Java 9 module is to really modularize the Java itself. So essentially, in this case, the Java 8 modules were to take the JVM, to take the Java JDK, to take the ecosystem and chop it into pieces. But why? Because the times when Java was introduced is very different from the times we are in today. And we are living in the days of serverless computing, function as services, microservices, and so on, and big data. So the change in time requires change in how Java will be used moving forward. Of course, 9 also gave us some better functional APIs as well. Well, enough of that talking, but let's talk about what happened since Java 10. Java 9 was the last water hose release of Java. And if I ask developers, right, if I ask you, can you think? So let's give this a try. We got quite a number of people on the presentation today. So let me ask you a question. Please type into the chat line. If I say Java 8, what feature comes to your mind? So type that away into the chat and see what we can think of. And lambdas, I hear that. Mayur is saying lambdas. Go ahead and say what comes to your mind. You can repeat that: streams and streams and streams, streams more, functional interfaces. Awesome, right? A datetime API. Well, that's interesting. Deva said datetime API. Now, look at how many times we saw streams and map in there, which is a bit of a disservice because, don't get me wrong, streams are important, lambdas are important, no doubt about it, but how many of us ever mention completable futures? Not a single human I've seen ever said completable futures. Completable future is such an important feature, and yet we don't talk about it. Why? Because a lot of these features, unfortunately, or in the shadow of lambdas and streams. And if you are a developer behind a very interesting feature in Java, how sad it is to be able to release it when it goes into the shadow of some major release feature at that time. And that's exactly the point about Java, where it was Java was being released every few years. Their goal was to release every 3 to 4 years, but it ended up with about 7 years. Now, why? Because they are developers like you and me. When the boss comes around and asks the question, how's it going? What do you normally say? I'm almost done. And the word almost done usually means 7 years later, we release the product. Well, they wanted to really make the change to it. And Java 10 was the very first release of Java that was done incrementally every 6 months. And I'll talk more about this incremental release a little later on. In that regard, Java 10 has only one significant language feature, which is really the local variable type inference. So what is local variable type inference? Now I can say a string greet is equal to hello, as you can see in here. And once I create the string, I can output the greet, and you can see the value is being displayed as hello in the output. Now, on the other hand, if I were to say greet.foo, notice what the error message really is. The error says variable greet of type string does not have the function foo. Just keep that in mind. Now, I'm going to go back to this code and change this to a var and run the code. It still worked. But if I go back over here and ask greet.foo, notice the error message. It's exactly the same error as before. It says local variable greet of type string does not have the function foo. So in other words, what does type inference really do for us? Now, one of the things I want to quickly emphasize is that there is nothing called a var type. I've heard programmers use this word loosely, and I always correct them when they say it. When they say, what is the type of greet? Sometimes they say, oh, it's a var type. No, there's nothing called a var type. So what does Java really do? At compile time, Java literally replaces the word var with greet for us internally. So in other words, most of the time, the type inference replaces the type with the type you would have typed. And occasionally, it can even do better. So it is either the same as what we do, or sometimes it's even better. Now, obviously, just to prove that point, I know a lot of times people are really afraid of these features, but it's important to really understand it. So let me show you quickly here, if you don't mind. Notice I'm using the word string in this code. I'm going to go to the command prompt right here, and I say javac -d, and I'm going to put that into temp classes directory, and I'm going to compile the sample.java right there. Now that I compiled it, what I'm going to do here is to run java p -c -p. Those have been set already on my system as aliases. So I'm just using java p with those options. And I'm going to say temp classes sample.class, and I'm going to take a peek at the bytecode. Notice when I look at the bytecode, that is the bytecode that got generated from the Java code. I'm going to highlight that line right there and leave it right there for us. So let's leave that alone. Let's now go back to the code one more time. And I'm going to say var right now and run the code, and the code executed. Now I go back to the command prompt. I'm going to compile the code one more time. But before I compile it, let me blow away everything in the temp classes directory, so I'm not reusing anything that got compiled. Now I recompile the code. And once I recompile the code, I bring up java p one more time, and I pop it up. Now I'm going to show you the two files. I'm going to switch between those two. You can see the one on the left is highlighted. The one on the right is not highlighted. You notice the only difference between those two files literally is the highlighting itself and not the content. So what does that tell us? The code that got generated from the variable type inference was no different than the code where you put the type yourself. So what does that really mean to us in the long run? What that means to us in the long run is that when it comes to Java, The type inference simply is a friend. The type inference simply, I often call type inference as a wink at the compiler. You're winking at the compiler and saying, hey, compiler, I know what the type is. You know what the type is. Do you want me to spend the time typing all that for you? And the compiler, smiles at you and says, no, dude, keep going. We are good. So in other words, you're not wasting your time typing it. Now, obvious question is, what's the saving? Well, the saving is, notice instead of typing the word string, I typed var, we clearly saved 3 letters. Now, obviously, that's not a big deal, isn't it? So the big deal here is not this case, but when you have a case like so, where you have a map of, let's say, integer, comma, a list, or even worse, a map of a list of, and then you have these going all the way, and suddenly you have so many angle brackets, you have bruise on your hands at the end of the day, and the family says, what's up with all this? Oh, I've been working with angle brackets at work today. Well, this is where using a type inference can really help us. So the question here is, but there's a shift in there too. I'm not sure what that shift is. I'm sorry. In the bytecode, maybe you're saying I didn't see any difference in the bytecode. Sorry. So essentially, in this case, what we are noticing is we don't have to spend the time and effort saying the type when the type can be inferred really well. So as a result, we are not wasting our time communicating the type information. Now, obviously, this is one of the features that's controversial. Programmers are not too thrilled about it, but the point really is don't force it on programmers. We got to get comfortable to use it. And the point really is when we start using these, the way I see the type information is the road signs often. When I move to a new city, I don't know where the post office is. I don't know where the library is. But when I live in a city for a few months, I know exactly where these are, and the signs are of no help anymore. Similarly, when you're new to a project, these things can be useful. But when you work with a code base for 10 hours a day, these become a noise over time. And we can substitute with editors and IDEs. You hover over and they give you the type. So the type is not needed most of the time. And also have to emphasize, I used to be very apprehensive about this myself, but now that I program in different languages where type inference is very common in those languages, I've gotten used to it as well. And I'm more, in tune with type inference. Now, of course, local variable type inference can be used with the for loop as well. So names, for example, in names, and you can use it like this. You can also use it with the try as well, if you will. So essentially, you can say try, and you can say var resource equal to new resource, and you can create an object like this, for example, and so on. So you can either use it with a local variable as max equal to 100 like this, for example, or excuse me, with the for or with the try. You cannot use it with the field. You cannot use it on a parameter either. And I think those are good restrictions, especially the one with the parameter is a restriction I hope stays for a long time. With the field, I think over time they will start supporting it because that's something you could do in other languages very nicely as well. Well, that's basically about Java 10's type inference. Java 11, of course, as we know, is the first version of Java that started the trend of a 6-month release cycle. And Java 11, Java 12, every March and September, we are now in Java 15. So what are some of the beautiful things that we have in Java today? And one of them is this phenomenal switch expression. I cannot tell you how happy I am to actually see this. Now, let's start with the word expression versus the word statement, if you will. Oh, one comment here by Jeff here is on the line with the system I happen to be looking at right now, you have a huge, okay, you can look at the output on the chat. That's pretty incredible. That's the easiest way to get old and die, to look at that kind of, a type in front of you. So thanks for sharing that, Jeff. You made my day. That's you're hilarious how complex that could be. Definitely you want to use a var on the left side at least to get away with that. That's beautiful. So expression versus a statement. Now, think of the word expression and think of the word statement. Now, statement are normal in Java and languages like Java, but what do statements do? Statements cannot be of any use unless they cause side effect, because statements don't return anything back to the caller. So the only way to make use of a statement is to have a side effect mutability or change something in the system. It turns out in functional programming, purely functional programming languages don't have statements. They mostly have expressions. So in the case of Java, of course, we had switch statement in the past. And the question is, why is switch a statement? Well, the reason is a switch is a statement because they made it to be a statement. Now, on the other hand, what if switch were an expression? So let's entertain this thought really quickly in here for an example. So let's go ahead and say output process, and let's pass a 1 to it. Let's pass a bunch of more numbers into this. Let's say a 2 and a 3, a 4, 5, and a 6. Now I want to create this process function. So what is the process function going to do? Let's the process function return a string, and I say process takes an input, which is of type integer. But I'm going to say return switch over here and then the input. I cannot tell you how happy I am to put the word return and the switch on the same line. So now switch is not only a statement, a switch is also an expression. Now the beauty of this is over time, you can refactor your code from a switch statement to a switch expression. Now, what are some of the benefits of a switch expression? The first benefit is it is concise. You're not going to write the nested if-else statement that's so ugly and nothing we are really proud about. This becomes a lot more concise. Secondly, there's an automatic break at the end of every case. So you don't have a buggy code, an error-prone code, where we kind of look really ashamed and embarrassed saying, oh, darn it, I forgot to put a break one more time. Well, there's an automatic break through every single one of those. So let's go over here and say default, and I'm going to simply say whatever. Let's just start with the default value really quickly. So notice when I run the code, it simply said whatever for all those values in here. But on the other hand, what I'm going to do is to then say for a case value of 1, notice we are using an arrow. Don't confuse this with lambda. The syntax looks a lot similar, but it's not a lambda. So I can say 1 over here and return a 1 for 1. Likewise, I can say case 2 and 3, and I can simply return a 2 or 3 here, as you can see, and that gives us the value 2 or 3 for both 2 and for 3 as well. Now, obviously, what if we really wanted to do some extra work for some other value? Well, you can put a little curly braces right in there, and I'm going to simply say, for example, let's go ahead and say output right here. What do I want to output right in there? Let's go ahead and say in here, a called, for example. Then let's say an yield and a result for, let's say, 4. And return it. So you can even have a multi-line code in there if you really wanted to, because you wanted to really do some extra processing, you can put that in there as well. So that is a switch expression. Now, one of the reasons I'm really excited about a switch expression is, not only is switch really awesome in the way it is today, but it's going to go towards something that I'm eagerly waiting for, which is a pattern matching syntax. And within a year or so from now, we're going to have pattern matching in Java. And that's going to be absolutely phenomenal, because with pattern matching, we can receive different types of data, and then we can extract data from those pieces of data by doing pattern matching. Things I've enjoyed in languages like Erlang and Scala and Haskell, we can now make use of it in Java in a very nice, concise manner as well. So really amazing features that we can look forward to as time goes on. So that's basically what a switch expression provides. And like I mentioned, we can continue to use the switch statement, but we can start refactoring to a switch expression. And also we can start using switch expression for any new code we are writing. And notice in the highlighted code that you see here, there is absolutely no mutability, no side effect. That's one of the benefits you get out of this is you're not causing side effects in the code. So the code becomes easier to reason, easier to maintain, easier to parallelize as well. And all the benefits of immutability, we are able to reap here as well. So that's basically what we get from a switch expression. Along the way, if you have any questions or comments, absolutely please post them on the chat. I'll be delighted to listen to your questions or thoughts and respond to them along the way. So with that said, let's move on to the next one. Next one is the text blocks I want to talk about. Now, before I talk about the text blocks, one of the things we often think about is, Java is beginning to move at a nice accelerated pace, but sometimes developers use words that are not maybe, negative, but they are eager to share their experience, but might come out negatively. So one comment I've heard quite often is, oh, now Java is stealing things from other languages. And I really want to spend a time on that phrase because the more important thing here is language evolution really is important for the future. You don't want one language to do certain things and other languages to be left alone. We want to learn from each other and improve the boundaries of what we do. That's extremely important. Secondly, Java is really innovative. And let me pause for a minute and share with you a couple of examples about it, and then I will tie it back into text blocks. When I saw Java Lambda expressions, I'll be honest about it. I said to myself, big deal, Java has Lambdas, but so do other languages. So why should I care? And so in a very reluctant manner, I started looking at the Lambdas in Java. And I remember looking at invoke dynamic, and that blew my mind because Java, as we know, is not the first language to bring lambdas. In fact, we could all agree it is one of the last languages to bring lambdas. However, they just did not throw lambdas into the language and go home. Instead, they said, how can we make lambdas A, backward compatible, and B, how can we make it really perform well? And to me, that is the genius of Java. That is the innovation of Java. So what Java developers of the Java language did is they said, we want backward compatibility. We want you to be able to send lambdas to the good old thread constructor, for example, and they came up with this idea of functional interfaces as opposed to function values that a lot of languages do. Secondly, before the time of lambdas in Java, a lot of languages on the JVM were using anonymous inner classes. So every lambda resulted in a penalty, more garbage created, more garbage collected. Well, Java could not have survived with that model. So they took the time to innovate and came up with the invoke dynamic that really eliminates the need for inner classes. And so you have references to functions directly. And to me, that is what I enjoy about Java is the innovation is not in language features, but the innovation is how these features are implemented. A case in point is text blocks. Let me explain where the innovation is with text blocks. So let's take a look at an example of this. So I'm going to go ahead and create a function called the greet, and to the greet function, I'm going to send Sarah as parameter. And in this case, I want to create a multi-line string. So let's say public static, let's say string greet, and takes a name as an argument. Now, in this example, we all have written code like this, isn't it? So we write a message is equal to, this is the first line, and then what do we do? Then we say return message, but before we return the message, right within here we say a message plus equal to, this is the second line, and then the next line, message plus equal to something along the lines of, this is the third line. And then, of course, the fourth line line comes after this, and that is usually followed by this life sucks, right? So basically, this is so boring, and we will never want to show this to our children because they would look at this and say, that's what you do for a living, and they never want to take after a profession after that. So that is really a lowest point of writing the code, isn't it? Well, the good news is we don't have to endure that pain and the resulting embarrassment after that. So we can write code in a way it actually is really nice and elegant. So what we can do is to put 3 double quotes right there, as you can see. So I created a 3 double quotes, and now we are going to say right in here, this is line 1, and let's go ahead and say, welcome to modern Java. We can, write code with low ceremony. And of course, we can then say, oh, how are you doing today? So I can even put a double quoted string with no escaping within right there, as you can see. Now, there are a couple of things I want to quickly point out here. I said innovation. Well, the first innovation is I have used multi-line string in multiple languages. Oh, I program in 15 different languages. What I'm telling you in so many words is I'm not good in any one of them. But I love these languages. I like those languages. But I got to tell you, when I use multi-line strings, which are called as here docs in multiple languages, I have to cry a little bit because my most recent experience, this happened about 4 months ago. I had a piece of code which was using here docs in another language. It worked in the past. The language version I upgraded and the code quit working. And why did it not work properly? Because the indentation was off and I literally had to waste 15 minutes fixing the code. Now, 15 minutes of fixing the code, getting 0 business value is not any helpful at all for me. But look at the innovation here. Java decided to do a few things for us. The first thing I want you to keep in mind is this whole thing is processed at compile time, not at runtime. So at compile time, this is compiled into a Java lang string. So they did not introduce a new class. They did not introduce a new type. They reused what is already there. So this is compiled into Java lang string. If you compile this to the bytecode and take a look at the bytecode, they are loading up a string into the memory. That's what they are doing really. Yeah, Benish gives a few claps for that feature. Absolutely, I love that. I love the way they have done this. So this is really implementation in the memory of a string itself. Secondly, notice what they did here. This is an algorithm that sensibly looks at the indentation and says, you didn't really mean it, did you? So as a result, notice in the output, there is no indentation at all. So when I run the output, you can see right there, there's no indentation because they smartly removed the indentation. Of course, if you were to go ahead and introduce an indentation right there, then they are like, sure, you want it. And so they give you the indentation, as you can see at that point. So indentations are done properly in a very sensible manner, as you can see. Now that we wrote that, of course, we got our friend Sarah, whose name is coming in here. So how are you, comma, let's say, and I want to put a name here, a dollar name, and then comma. And we can say replace, for example, and then we can replace a dollar name with the name if you really wanted to, but it does require typing properly. And when I run the code, it says, how are you, comma, Sarah doing today? So we were able to replace the words into it as well. Alternatively, you could also turn this around to a string dot format. And in this case, you can change this to, as an example, a %s, if you will. So a %s right there. And then, of course, instead of today, and you could also put here a %s, for example. And then, of course, in this case, you can simply replace that with maybe the name, if you will, and then a new, let's say, java.util.date, and bring the date object in there and display it as well. So you can see how you are able to use a format or a replace to replace parts of it. Eventually, Java may introduce interpolation like other languages do. It doesn't do it today, but that's an example of a multi-line string. But not only that, there are a few other interesting things that are in here as well, in addition to what I showed you. And that is, a lot of times when we use a multi-line string, sometimes we use it for a string like you see in here, where I might create a mail merge and send personalized email to people using something like this. However, there are times when your multi-line string may be a XML object, or it could be a JSON object. And oftentimes, if you are like a lot of other programmers and me, you don't type all that stuff. We use this best technology humans have ever invented. It's called copy and paste. So you copy and paste it from somewhere else. And when you do, what typically happens is there is a lot of spaces in the very end, which becomes a problem. Well, here's the good news. When you run the code, notice there is no space in the end. And you're like, really? Of course I cannot notice it. It's a space. How would I know it? Well, fair point. So what I'm going to do here is to do a replace just for us to see. And I'm going to replace the space with a little tilde symbol so we can actually see where the spaces are. So when I run the code, you can see there is no space after Java in that second line, even though there is a lot of space after Java in the highlighted part right there. But in the output, you can see there's no space after Java. But you say, gosh, that's great, but I really want to preserve that space. How do I do it? Sure, you can if you really wanted to. So there's a syntax for doing that as well, where you say, hey, that space really is important to me. Could you please preserve it? And you can see that it's actually preserving it as well. So you can definitely do that also in this case. So that gives you a nice idea of how you can do things. Similarly, you can put a little slash in the end. And what does that do? It merges those two lines together, as you can see. So that line ending Java is merging with the line we can write code with low ceremony. So if you really want to indent it for readability, but you really want them on the same line, you can absolutely have them on the same line as well. So those are some of the things that Java has done really well in bringing the multi-line strings to the JVM, and we can benefit from this. Performance-wise, we are not doing any processing at runtime. All this processing is done by the compiler. So by the time you produce your bytecode, everything is done and ready for you. And that's basically how this has been implemented as a text block pretty nicely. So text blocks are a standard feature in the language today. Then comes along something really powerful again, which is records. Now, not only are these features great by themselves, they also play really nicely with other features as well. So what do records really do? Now, we all have done this in the past, isn't it? We want to create a class called person. Well, maybe we'll create a class called person, and then what do? We say private string first name. Then we say private, private string, and then we could write in here the last name as well. Maybe potentially we'll make them as final. We don't want to change it once we create it. Then we create the class person constructor. Then we say string the first name on this and a string last name on this. And then of course we go back and type this as this dot first name equal to first name. You know where I'm going. When you're done with this, you say public, of course, you say string get first name, and you better write the get first name function. And then of course, you also write the get last name function. Are we done yet? No, you write the equals method. You forgot to write the hash code. Then you come back and write the hash code. Oh, you got to write a toString method. It seems relentless. We got to write so much code. And why are we doing that? I know what you're thinking. You're thinking, oh, come on, Venkat. I never do that. I just type the field and I gently right click on the field. And before I can blink my eyes, my IDE vomits the code for me. Well, if that is the case, what happens? You need to live with that vomit forever, isn't it? And those vomits, of course, are vomits with the dry eraser. You cannot erase them. They are on a permanent marker. Well, you live with it forever. Or you got to use, like Aaron said, tools like Lombok. Don't get me wrong, Lombok is awesome. but I don't want to be forced to use a tool because the language is inadequate, right? So why should I use a tool when a language can do the job for me is the real part in this case. So as a result, what do we do in most of these cases? These are called data classes. So data classes are very popular in a lot of different languages. Haskell has it, Scala has it, Kotlin has it. So many other languages provide data classes. Well, Java wanted to provide data classes, but if they called it data classes, everybody will know, so they called it records. So it's our little secret. So what's a record? It's a data class. So a data class really is an immutable object. Its properties cannot be mutated. And you have an offer of buy one, get five free today. So you buy a record and you get a constructor, the getters, the two equals method that is provided for you along with it, the equals method, the toString method, the hash code, all of those are provided. So write the record and it comes with all those 5 things for you. So let's give it a shot. So record over here, and the record is called person. So the record person has a string of first name and let's say a string last name written over here. And I don't have anything else with the record. So that's a concise code, but zoom into it, you see those 5 things I talked about: the constructor, the toString method, the equals and the hash code method given to us as well, and the getters for these fields. So now I can say in here, let's say Alan is equal to new. Well, person, and we'll say Alan, comma, right here, and we'll bring in Turing into the mix. So right there, and then we will output Alan right there. Notice I did not write anything extra for this, but if you look at the output, really, what you're going to get at the very end, oh, wait a minute, record, of course, this is a feature available with the preview feature. So it gives me a warning and it says duplicate class person. Pardon me. I already have a person class sitting here. That's the reason. All right. Now let's get back and write that code. So when I run the code, notice what it says: person, and then first name Alan, and then last name Turing, and gives us that result right there, as you can see. So, but how do I get the first name of Alan? So you can say first name like so, and then I can also do Alan dot last name like so. Notice I'm not using the word get for these, but I'm calling them like they are functions, if you will. So as a result, you got Alan's first name and Alan's last name. Not only that, you can then ask the question, is Alan the same as dot equals? And I'm going to say in this case equals, well, new person whose name is Alan, of course, and the last name is Turing again. And notice that in this case, the result is a true. But if I change the name a little bit, it says false, because after all, they really are not equal. So equality is implemented by comparing each of the fields as well. You cannot modify the first name or the last name. Those are immutable, so you're not allowed to modify those. And that's basically what a record is. Now, just by itself, I would say record is pretty awesome. It eliminates the need for using third-party libraries like Lombok. You're still most welcome to use Lombok for a lot of other things it does, but you don't have to use it for just this purpose. Secondly, it reduces the verbosity in the code. Now, what if the first name shouldn't be something of a particular, value? Maybe you want to do a check on a first name. Maybe somebody has a first name called delete all, rows, or a first name called drop database or something like that. And you want to really check to make sure they don't get away with such ridiculous names. What can you do? Well, you can then create a canonical constructor. Notice that constructor that I'm creating right there. And within here, I'm going to say, let's say output, do validation here, and I can simply run that code, and you can see do validation here is being called at the very top. So I can even get access to the first name, and I can even get access to the last name here as well. And of course, as a result, you can see that I can verify those details. I'm not suggesting this is true or false. Maybe in your domain, in your system, somebody should not have the same name for the first name and last name. You know what? It's perfectly fine to have such names. In fact, I like such names, right? But the point and even when they're longer, that's even better. But the point really is we can still say if the first name is equals to the last name, then maybe we can say, something along the lines of, throw new runtime exception, and then, please check or something like that, just to verify if this is really true. And if it is, we can, always bring in an exception to process that. So in this case, we can have an exception. So just as an example, I change it to Alan and Alan, not Alan annotation. So run the code and you can see that's going to be a failure right there at runtime, and it gave us an exception to say, sorry, you cannot do that. So the point really is that you can even write a specialized constructor if you want to. But having said all of this, while records are really awesome, one of the things I love about records is where this is going to be used with pattern matching. Let me give you a quick example of what it may look like in the future. Now, this is obviously, we're looking at about a year before we can do this, but imagine for a minute that you have a record. Oh, question here. Can I apply all access specifiers in record? Can I apply all access specifiers? Yes. So you can do, okay, so a couple of clarifications, Deva. So the first is your records inherit from, thanks for the question, by the way, records inherit from record already. So you cannot extend your record from a class because it already extends from record. But you can implement your interfaces in a record. So you can say class person implements friend. That's perfectly fine. But you cannot say class person extends animal. You cannot do that because, sorry, record. So records already extend from a record class, but you can implement interfaces. You can make public and private things. Absolutely, you can do that too. On the other hand, records are final. So you cannot override from a record. So records cannot inherit from anything, and records cannot be inherited by anything. So there are a few restrictions, but for most part, you can use things like public and so on quite naturally. You can put methods within records as well if you really wanted to. That's perfectly fine too. Now, having said that, well, records where they're going to shine is the following. Let's say for a minute that I have a record, let's say a record called the stock, and it contains a ticker, and let's say it contains a price for the ticker. So my record now, and this is, I'm going to simply say hypothetical, right? So I'm saying hypothetical because this feature doesn't exist today, but it's going to come in the future. And what you can do is you can bring in a switch and you can do some data processing on the switch or a pattern matching syntax. And what you can do is you can say case and you can say stock, and you can call this one as T and P, just as an example. And then you can put a little arrow and you can access T and P right here within this code. So the point really is that T will correspond to the ticker and P will correspond to price. Now, this is a feature I absolutely love, and I'll expand on this a little bit. One of the features I really like is a feature called destructuring. Now, I do crazy tweets oftentimes because I'm that excitable. So when I get excited, I just tweet random things. So one morning I was working with destructuring in another language, and I really enjoyed the code I was writing. So I opened up the Twitter and I tweeted, and my tweet said, today's tweet is sponsored by destructuring. And within a few minutes, Brian Getz, who is working on Java, replied to the tweet saying, I neither confirm nor deny that Java will have destructuring. And I immediately replied to him saying, I know the answer already from your tweet, and I can't wait for the day when it's going to be available. Destructuring is one of my favorite features in programming. So what is destructuring? Well, we know what structuring is. So what is structuring? Well, structuring or construction is taking the pieces of data. So you go from pieces of data to an object of some sort. So destructuring, on the other hand, if you will, so destructuring or deconstruction is taking an object and tearing it apart into pieces of data. So in other words, you're saying, I have an object called stock, but I want to take that stock object that's in the data and I want to tear it apart into the ticker and the price separately. So I want to extract those data out. So destructuring can minimize the verbosity in code and it reduces error and makes it really easy for us to pull things out of an object. And so records are going to be mixed with destructuring in the future when it comes to pattern matching, and we can really enjoy that. We're not too far away from that. My guess is about a year or so, we'll be able to do that pretty nicely. Now, having said that, the next thing I want to show you here is, I like to call this a smart casting. They call it pattern matching with instance off, but let's go to an example really quickly here. I'm going to output process with a 1, but I'm also going to output process with, let's call this as a hello right in there. Now, I want to go ahead and define the function process. So public static, let's say, and let's say in this case, I'm going to return a string process, but it takes an object of some kind of a message that is arriving. And these messages could be of different types in different format and so on. Now, I'm going to say if the message is an instance of an integer, I'm going to say then, maybe we'll say return in this case. So in that response to it, it'll say return, we'll simply say got a number. So that's great so far. And otherwise else, we'll simply say return, we'll say something, something else. Okay, so otherwise return something else. So when I run the code, you know, it got a number, got something else. But then I say, if the message is an instance of a string, then I'm going to simply say over here, return got a string. And let's start with that first. And I'm going to run the code. Now in here, it says got a string, but I want to say got a string of length, and I'm going to say plus. And in this case, I'm going to say message dot length to get the length of that message. Now, you know this already, right? That code will not work. Now, why doesn't this work? Because message, which is of type object, does not have a length with it. So what do we do in Java to work with this until now? You put a nice, beautiful parenthesis around it, and then you put a little bit of a string around it, and then a little bit more of a parenthesis. It almost feels like writing Lisp at this point, and then we run the code, and it's like, you're good, right? Now, does anyone remember what this feature is called in Java? Yeah, they call it casting. I call it punishment. Because would you like to program with somebody who is behaving like this? Let's say you go to them and say, hey, did you go to the movie yesterday? And they say, yes, I did. And you ask them, how was it? And they say, how was what? And you're going to roll your eyes and walk away, isn't it? This is exactly how Java behaved just now, isn't it? Hey, Java, did you go to the movie yesterday? Yes, I did. How was it? How was what? And you're like, really? Never mind. And when I write code like this, I always ask the question, do you work for the compiler, or does the compiler work for you? Well, oftentimes I feel like I am working for the compiler. The compiler comes around and says, how's it going? I'm like, I'm typing as fast as I can. Yeah, keep going. I'll be right back from the lunch, and goes away. So the point really is, this becomes really effortful, if you will. One comment from Jeff is the Gozo language always did the cast automatically after a type check of the if statement. Gozo does it, Groovy does it, Kotlin does it. Most languages that don't want to torture developers do it. And the good news now is Java does that as well. So you don't have to endure that pain after all. So what can we do? So we can take that line of code, but with a little bit of a difference here, I'm going to say stir.length, where I'm going to just go up here and put the stir right in there next to it. So if you notice now, we simply said, well, finally the compiler is working for us, as you can see. So now you are saying, hey, if this check was passing, then do me a favor, give me str, where str is a reference that is of type string, but literally refers to the same instance message over here. So as a result, you can nicely use that in the code. not only can you use it in here, you can also use it after an AND statement as well. Sorry, an AND expression as well. So for example, you can do something like message is a instance of a string str and str.length is greater than 5, and then you can write code like that as well. So essentially, this is simply a casted variable, and make no mistake, this str is available only within that scope. You cannot use it outside the scope, and within the scope, you can actually use that string very nicely. So that's an example of how you can benefit from smart casting, or what they call as pattern matching with instance of. Well, the last thing I'm going to talk about in terms of the features we have today is one other thing that just got introduced in Java 15, which is called sealed classes. So what are sealed classes? Now, let's step back for a minute and talk about it. We know what abstract classes are. So abstract classes can have any number of derived classes. So derived classes, but can't have any instances, any direct instances. On the other hand, a final class, may have any number of instances, but can't have any derived classes. So if you notice these two, those two are two different extremes, isn't it? On one extreme, you can have 0 derived classes. On the other extreme, you can have as many derived classes as you would like. But there are times when you want a little bit more control, where you say, I have a class, a base class, if you will, and you create your base class, and my controlled subclasses. So in other words, you want to create a hierarchy of classes, and you want to control what that hierarchy is. And you don't want anything other than what you define in your hierarchy. Well, that is exactly where we are going towards what's called algebraic data types. So algebraic data types are a closed hierarchy of classes. And you can say, hey, here is my base class, an abstraction, and here are my derived classes, and we are done. You cannot have anything more added to these hierarchy unless you are the authorized person with access to the source code for the base class. So in other words, as an author of a base class, you can very well control what your subclasses are. Now, what is the benefit of that? Well, there are a few different benefits of this. The first benefit is that you get to create a closed hierarchy. The second benefit is that you can write pattern matching eventually, where the pattern matching does not have to have a default route. If you have said, I have 5 children classes, derived classes, here are the things I'm going to do for each one of them. Hey, guess what? I'm done. I don't need a default. And an added benefit of that is tomorrow, if you decide to change your hierarchy, your compiler will give you an error. So you got to fail fast, because the compiler can verify and say, hey, look, you have 6 children classes, but you only have 5 branches. What's up with it? And it can give you an immediate error. So the code is not going to, fail at runtime. You get a compile time error that's going to knock your code and say it's wrong. So this can be a really powerful way of checking for these kinds of discrepancies as well. So let's take a look at an example of how that would look like. So I'm going to create a little example here of a traffic light. And this is going to be equal to red. And I'm going to output the traffic light right in there. Now, what in the world is a traffic light and then equal to red? And just to emphasize, let's go ahead and say this is a traffic light that I'm going to create as a class right there. So let's go ahead and create a traffic light. Oh, your classes you create for sealed classes, they could be sealed classes, but they could be sealed interfaces as well. So you can create a sealed class if you want to, or you can create a sealed interface. It's entirely up to you. So let's go to the command prompt. let's go ahead and edit a traffic light.java right there. So my class, I'm going to say sealed class called traffic light. So I've created a traffic light class right there. Now that I've created a traffic light class, I'm going to say over here, class red extends from traffic light. And I'm going to make this a final class called red. And I'm going to also go ahead and create one more class here, which is going to be called as, let's say, green. And finally, we'll create one more. We'll call this as yellow. So we got 3 different traffic lights that I've created right in there. So we created a sealed class called traffic light. Coincidentally, I put all the children in the same file. Now, because I put them in the same file, my traffic light is only allowed to have 3 derived classes, the red, green, and yellow, and nothing more. We'll come to that in a minute. So if I go back here and execute this code, notice it gave me red. But, question here. Is there any restrictions on children classes to be in the same package? Vishnu, the answer to that question is the children classes are required to be in the same module. How does it differ from enums? Enums often are defined using a enum syntax, and they're all inside of that. Enums derive from the class internally by the compiler, but this is something you can write full blown. Enums are very difficult to put behavior into, right? Enums are really useful. You know, think of sealed classes as, think of enums as a specialized, small, teeny mini baby sealed classes, if that helps you, right? So enums are very restrictive. I wouldn't use an enum for implementing something with complex behavior in it. Whereas a sealed class are classes with normal behavior, except the hierarchy is restricted. So that's why I think of enums as a specialized case of sealed classes, if you will. It's rather constrained. A question, Bilal, is does sealed classes add another access modifier to Java? Yeah, they do, and we're going to look at that in just a minute. So in this case, we have the red that is coming through, and that worked. But I'm going to go here and create a broken light, as a lot of traffic lights are, right? So I'm going to create a broken light.java. And so what am I going to do? I'm going to create a final class called broken light. But what does broken light do? It extends from traffic light, if you will. So it extends from traffic light. So let's go ahead and copy that over. So extends from traffic light. So that's all I did. Now notice if I go here and run the code, I get an error. So what is the error saying? Look at the bottom line. It says broken light error, class is not allowed to extend the sealed class traffic light, so it doesn't permit me to add it. So, a minute ago I said it can be in the same module. That is true, but not always true. You still need to give permission for that class to exist. And I did not give a permission for a broken light to exist, so you cannot create it. So let's get rid of the broken light, sorry, that cannot exist. But then I say, oh, come on, I really need one more class, but I don't want to dump them all in that same file because that's too much of effort to put them all into the traffic light. Why can't I have it in another file? Well, yes, you can. So what you do here is, let's create a blinking light, which is a lot more positive, .java. So what am I going to do? I create a final class called blinking light, which extends from traffic light, as you can see right here. And of course, that's not going to work at the moment, right? Because I didn't do anything different for a blinking light as I did for a broken light, except I go to the traffic light and say permits. And I'm going to permit a red, a green, a yellow, and a blinking light as well. So now that I permitted all the 4 of them, the code runs with no errors, as you can see. So when I go back and execute the code, it still said red with no errors. But to answer your question, that's the permits that you got added, right? So not an access modifier like a public or a private, but a permit simply says the traffic light as an interface, a sealed interface, or a sealed class permits the existence of these children in the hierarchy, and those are red, green, yellow, and blinking light. So a couple of things in here. If all the derived classes are in the same file, you don't need this part. So if I were to bring the blinking light into this file, I don't need the highlighted part, the permits part. If I have the files in different, if I have the classes in different files, then I can say permit and bring them in. And then as a result, I can have some here and some outside. But going back to your question earlier, Vishnu, is that you cannot still have a class outside your module. Your classes are still required to be in the same module as the one you are creating. So as long as they're in the same module, you're okay, even if they are in multiple files and multiple different packages as well. That's perfectly fine on the other hand. So those are the sealed classes that are available in the case of Java. That's right off the press, so to say, a pretty hot feature. Question here is it necessary? Preeti's question is it necessary to permit red, green, yellow as it in the same file? That's a really good question, right? So if I were to remove these from here because they're in the same file, what's going to happen. And as you can see, it's not happy with it because either you use it or you don't. You got to be consistent about it. And the reason for that really is, tomorrow, you may decide to move this to a different file, or you may decide to move it back in here. And when you do, you don't want to be messing with that. So that becomes really clear. Secondly, to answer your question, Preeti, is if I had it this way, then what happens is it becomes a little confusing as well. You look at that and say, oh, now to know what is included, I've got to see this collection here, but I got to read through the file. Keep in mind that this is a very trivial example, but in reality, this class may extend quite a bit as well. So now when you come in and look at that line, you don't get a really true picture, and you have to combine the two together to know. So the cost of writing it is so small, and the cost of not writing it is quite big as well. So the question is how to extend blinking light as blinking red. Well, you have to create the hierarchy for that. And if you decided to make it a final or a sealed, you cannot inherit if it's a final. If it's a sealed, you can extend the hierarchy from that further. So it's the same transitive relationship, if you will. So you can say, hey, this is sealed. And then as a result, you can extend a little further and add more things to it. So when you define a class, to answer your question, is you can say whether your class itself is final or itself is sealed, and so on. So that is going to control, if you will, Zaujun, your question to your answer is, it decides on what you can add based on what definition you provide in there. And John is asking, does a superclass no subclass implementation break polymorphism modularization? That's a really good question. That's a brilliant question. From a design point of view, that doesn't seem like a great idea. However, in this particular case, because it's a closed network of classes, that becomes an exception to that rule. In general, John, I would not design that way, but this is more of an exception than a norm. So in this case, of course, because we are really defining a closed structure or a closed hierarchy, we are making this. But also keep in mind, the only dependency is telling what you are permitting. If inside the class, if I were to use a red or a green, I would still claim that as a bad design, so I wouldn't do that. So this is only an exception than a norm in terms of saying, you're not making the class depend on it. The highlighted part, think about it as a configuration that is outside of the class for all practical purposes. So it appears like you are coupling the base to a derived, wherein you really are not. It's more of a configuration you're providing. So potentially, hypothetically speaking, they could have provided a separate configuration where we could have said, hey, this particular a class or interface, here are the possible children, but they just combined it to make it a little easier. But yes, from the design point of view, I would not want that kind of relationship as a bidirectional dependency. That's really not a good idea. Well, okay, so let's talk about a few other things, switching gears. I showed you the features in Java, but Java is moving at an accelerated pace right now. And one of the things I want to emphasize here is that Java is not moving at let me say, an uncontrolled manner. The developers behind Java are not infatuated with features. Their goal is not to say, oh my gosh, let's change Java, let's go shopping, find out what's available, and throw that in. They're taking a very pragmatic approach, and they are taking a very reasonable approach in evolving Java. So the emphasis I want to place here is Java is evolving in a responsible manner. So they're first asking the question, what features are useful for Java programmers? Secondly, they're asking the question, how feasible it is to implement those features realistically now without hindering the ability to implement features in the future. And then the third thing they're looking at is, how can we make it useful so it performs really well for Java and can be used very effectively with backward compatibility as well. So Java is growing at a very reasonable pace. And as a result, we are seeing quite a bit of growth in Java. Well, what we now have is a shorter release cycle. And I want to spend a minute on this because there's a lot of confusion around it. You know, when people started seeing that Java is being released every 6 months, there was panic. I want to emphasize one thing. Java is not being developed every 6 months. Java is being released every 6 months. So what is the difference? Imagine you're standing by a train station. There's a train arriving every 10 minutes. Guess what? The train that just arrived, it did not travel for 10 minutes. It may have traveled for 2 hours. Who knows? It may have traveled for 2 days. But every 10 minutes, there's a train arriving. So take Java 10, take Java 11, take Java 12. They were released in 6 months interval. But that one feature in Java 10, they took 5 years to implement it. They didn't take 6 months to implement it. The feature that went to Java 12, they took 3 to 4 years to implement it. The difference is when a feature is ready, they don't have to artificially wait until other features are available to release it. So when a feature is available and when a feature is ready, it can go out either in the next March or it can go out in the next September, whenever it is. So features are being released as they are becoming ready. Java 12 or Java 13 or Java 14 are no less in quality than any other version of Java. So the frequent release of Java is not lowering quality, it is lowering the time for releasing. Now, there's a name for all of these, right? Sometimes we use it without realizing what it is. It's called Agile Development. So essentially, the developers behind Java truly embraced agility. Because what is Agile Development after all? Agile Development is being adaptive. Agile Development is being responsive. Agile Development is not holding onto your code and releasing it as frequently as you can. So Java is agile today than ever before. The development is taking longer as it did, but the release is taking shorter because they don't have an artificial deadline for products. And if you go to them and ask them what's going to be in the next release, their answer sincerely is, we don't know yet, because we're going to look at what we are doing. Whatever is ready, we're going to release it. And so as a result, the shorter life cycles are really benefiting them. How does it benefit us, the programmers? Well, we can focus on a single release and we can take these bite-sized improvements rather than being faced with this huge release and we focus on a few and forget a lot of other features. Now, with that said, a lot of these developments you saw already, those have been around for a while in different experimental projects. And those projects are continuing. And some of them are Project Panama. And Project Panama is focused on the foreign functional interfaces. My goodness, what does that even mean? Well, let's focus on this. We know what interfaces are, but more so we know what a functional interface is. Well, a functional interface is a single abstract method interface. Well, more important, a functional interface can be implemented using lambdas. So for a minute, change this word to lambda for a minute, if you will. Now what are we saying? A foreign lambda. Whoa, that's kind of interesting. So now what we are saying is that a function will be implemented in Python or JavaScript or C Sharp, and you should be able to consume that in Java. Those of us who have done JNI in the past never want to wish that on an enemy, isn't it? Well, what if really making calls to a code in other languages become natural? That's basically where functional interfaces, foreign functional interfaces are taking us. A lot of things you saw earlier came from Project Valhalla already and Project Amber. Well, in Project Amber, you have two things going, value types and generic specialization. Let's talk about value types before we go any further. So what really are value types really? So value types are essentially, let's see where I am. So I'm in the right place. Okay, so value types really, what are those? Suppose you create an object. Let's say you are in a function called, let's say a public static, let's say foo. Now within this function, I'm going to create, let's say, int max equal to 100. Now, where is this max being created? Well, everybody knows the answer to it, right? It's created on the stack. On the other hand, if I said, something like a person, Peter equal to new person. Now, where is this object being created? Everybody knows the answer for it on the heap. But the question is, why? What if I can say something along the lines of stock equal to new stock? And what if this can be created on the stack instead of heap? Well, now you know what a value type is. So value types are created on the stack while the reference types are created on the heap. Not only that, one other benefit is value types can pack really well compared to reference types. Let me share with you an experience about it. I recently worked on a project where it was a big data project and it was math intensive. So we sit there and optimize the algorithm and we take a little sample and run the code. It works really fast. And we were really happy. Then we take on a realistic data set and we ran our algorithm on it. And it would take 7 hours, 6 hours to run. And we were sitting and scratching our head. What are we doing wrong? What are we doing wrong? And we spent a couple of days trying to optimize every corner we can turn. Nothing helped. And then out of frustration, I just said, excuse me, I'm not really sure what's going on. Can you do me a favor? Can you start turning on the logs to see when the garbage collector is being called? And guess what? Our algorithm, poor algorithm, I suspected, our algorithm ran like that and produced the result. And then it would take 20 to 30 minutes on garbage collection. And we were like, oh my goodness, we are spending all this time on garbage collection rather than running the code. And I'm not even kidding with you. We went around and changed every list in the program to an array because we could not afford to create list of billion items. We convert to array so we don't spend time on garbage collection. And I cannot tell you how much I'm looking forward to this. Generic specialization and value types are all about really performance. You know, this is one of my desires. Before I retire or die, I want to be able to do it. I want to be able to say list int. Why not, right? Why can't I say list int? Why should I say list integer and have the auto boxing and boxing overhead? Why shouldn't I create a generic collection of value types? And when that happens, performance will be the biggest benefit of that. And that is basically what value types are. This is not an easy problem to solve. It is something that takes a lot of effort, but that's what they're working on. And Project Amber is about reducing verbosity so we can focus on solving problems. Right out of this Project Amber came quite a number of things. Oh, question here by Vishnu. This is very similar to what C++ provides out of the box. I never compare C++ with anything civil, by the way, Vishnu. I'm really sorry. And I say this out of respect because I spent 20 years programming in C++. And what I've learned is never speak about it in public anymore. So I will defer that question. So I say it out of respect for C++ and myself, having spent 20 years on it. If you say Haskell, we got something to talk about. No, just kidding. Well, the point really is that C++ template handling is really pretty sad story. What you're really looking here is something along the lines of C# in terms of, because C# has value types and reference types, C# has reification. It's not perfect, but they have done it quite already. So that's kind of what we are really aiming for in here. So having said that, one of the things with Project Amber really is, your smart casting, what we saw earlier, smart casting as in using the casting to perform pattern matching with instance of is an example. Similarly, the text blocks and so on are really the child of Project Amber. And out of that is pattern matching. I talked about this already. I'm really looking forward to that and see what shape it takes. But of course, the one thing that I'm really, really looking forward to is Project Loom, which is really about continuation in fibers. In Project Loom, you can create, whereas on a machine, you can create only thousands of threads, you can create millions of fibers. And the reason is you have what are called virtual threads. So by using virtual threads, the basic idea is you don't want your thread and the task to block. So with virtual threads, you imagine a virtual thread to be like a waiter in a restaurant. The waiter comes around and says, "Are you ready to order?" And you say, "No, I'm still thinking." And what does the waiter do? The waiter says, "Why don't you continue thinking? I'll be right back," and goes to another table to buzz around. In the meantime, you're like, "I want some water." It's possible that another waiter may give you water and walk away. So in other words, you don't hold a waiter hostage in a restaurant table. I hope you don't. So the point really is you have a thread executing and you have a task executing. Your task performs an IO. Your task is put on hold, but the thread is detached from it, and the thread goes on to serve other requests. And then, of course, when the task is ready after the IO is done, it can get attached to a thread and it can continue executing. So as a result, you can literally have millions of tasks running on your system because they no longer are bound to a thread. While your threads are in the past were tied to the to the operating system threads, right now in virtual threads, they are JVM threads and not operating system threads, so you can create a lot more. So this is going to really give you a lot more scale than we did before. So this is fundamentally going to change the way we do concurrency on the JVM. As a matter of fact, this has been in development for well over 10 years already. And maybe in another year or two, we'll be able to make use of this really well in our systems. So to summarize what we talked about, Java is no longer the same Java it was even only a few years ago. Some of the biggest changes started happening in Java 8, and then it started accelerating since then. And every release, we have been having some amazing capabilities and features in the language. I'm absolutely excited about where the Java is running. Well, one question is it similar to Go routines in Golang? Well, Go routines, Kotlin coroutines, a lot of these things are solving very similar problem. Java is going to similarly take a stab. And to answer your question, Vishnu, is that continuations are going to be data structures within the JVM. Of course, Java has its own twist on implementing it. So the concepts are not independent. Continuations, by the way, have been around for a much longer time than Go routines and Go. For example, language like CLU in the past actually had that as well. So it's very powerful features. One other comment or question here is, what language like Golang trying to make the core lean and clean? I feel like Java is trying to add a lot of features to the core, even though some new features are award worthy. Well, the languages has to evolve, right? If the language doesn't evolve, it's going to be dead. So there's always this balance we have to strike. And on one hand, you want the language to grow. On the other hand, you don't want it to grow uncontrollably. So Java is growing in a very sensible manner, in my opinion. And that's what I really like about it. So given that, of course, it's moving really well in this direction, and definitely it's a language that's exciting, a lot easier to keep up as well, because we are getting this in bite sizes as well. Well, that's all I have. I want to really thank you for your time. I got a couple of more questions here. I'll answer them, but if you have more questions, I'll be delighted to take them as well. One question from Deva is, Loom, will this be helpful for CPU intensive operations, or is it only for IO intensive? Really good question, Deva. This is really geared towards IO intensive. If your job is computation intensive, Loom is not going to help you, because when something is computation intensive, it's going to keep your threads busy. It's when you don't need the thread to be held hostage. So to your point, the whole thing about Loom is for IO intensive. But keep in mind that for IO intensive, a lot of things that we do today are really IO intensive. Microservices, talking to databases, and so on. So that's basically where it's geared towards, is the IO intensive operations. So they're putting their money where their mouth is. So that makes actually good sense in that regard. So I'll be more than happy to take if there are any more questions or comments as well. Thank you. Thank you. Appreciate it. Thank you.